Whoa, hey, it's been a while. Remember that rocket I made like a few months ago? It was called Falcon Bobby 2.0, and this was the flight if you forgot or you haven't seen it yet. So as you could probably tell, the parachute did not come out, and I finally have somewhat of an explanation. I can't actually remember if I explained it in the latest video, but basically, remember that motor case that I spent like a good hour or so last year modeling in 3D? Turns out there was a very fatal design flaw, and that was the kind of gaps in between the motors. And as you probably know, the way that the parachute comes out is from the ejection charge in the motors, and that releases a bunch of energy that shoots upwards into the rocket. However, since those gaps were in the motor case, most of that energy just flew right through the bottom of the rocket and not towards the parachute, and that's why yeah. So that's it. That's basically what happens if Falcon Bobby 2.0. I'm not flying it again. That rocket is gone. Kind of. I'll get to that in a second. However, in this video, I am going to be announcing the next model rocket that I am already building. I've been building it for the last couple of months, or at least working on it in some way. This is actually going to be the first video in a series of videos coming out discussing every kind of part of this new rocket, because honestly, it kind of needs its own individual series, which is why probably this video might not be too long, because I'm only going to be briefly going over everything. I'll cut to the chase real quick. The next model rocket that I am building, and hopefully will launch sometime this summer, is called Velox E. The E standing for electricity or electronic or something, I don't know. But why electricity, you might be asking? Well, it's because it's going to be the first model rocket that I ever make to use any sort of computers or microcontrollers on board to control things on board the rocket and also record flight data. Oh, this is going to go terribly. Specifically, I'm going to be using the Arduino Nano 33BLE, and I'll go into a lot more detail about this whole thing in the next video with all the programming and all that stuff. The microcontroller will then be able to read a bunch of data like acceleration and all this other stuff to be able to figure out at what stage of the flight it is at. Along with that, there's going to be a servo motor, which is just this spinning thing that will be on the top of the rocket, and when the rocket hits apogee, the servo motor will spin and will unlock a door that will deploy the parachute. So there won't be any need for the ejection charge of the motors. This is going to be a completely just automatic and electronic kind of way of doing things, which is probably way less reliable and way more complicated than just using an ejection charge. But I'm doing it anyway because I don't know. I've always wanted to have some sort of computer on board the rocket bar, like the cameras that I've had on a few previous flights. I don't really count that as like electronics. I've always wanted to have something like that that can control the rocket, and we can actually figure out how fast it went and how high it went and all that sort of stuff without kind of just guessing and eyeballing it. So yeah, that's like the main headline for this next rocket, and that's the biggest difference between all the ones I've made previously and this one. However, there's a few other very key details about this new rocket. The first one, and this is what I meant by Falcon Bobby 2.0 not kind of being retired. I'm actually going to be reusing Falcon Bobby 2.0's airframe, which is the blue cylinder. And I might be thinking that's a terrible idea because it crashed and also the airframe is very heavy. And you are correct. However, surprisingly, the airframe didn't take any damage at all during the flight, or very little, and it's very easily repairable. The only thing that really was damaged was the nose cone and the fins, which I guess just goes to show how strong it is, because it was able to withstand an impact from that height and from that speed. So that's why I'm using it again. But also, it's just going to save costs because it's a very good airframe, and I haven't really been able to find any other cardboard tubing the same size or the same strength for a reasonable price. Now that also means that we're going to actually be reusing the motor case along with it, because the motor case is glued into it and it's going to be basically impossible to get out again, which I'm fine with, because it did take a lot of effort to get that motor case working and not the size of a penny. You'll understand if you've watched this video. And what's better is that we don't have to worry about those gaps in between the motor cases like I mentioned before, because we're not actually going to be relying on the ejection charge from the motors to deploy the parachute. It's going to be the servo motor from the microcontroller. Now that does mean I'm going to have to stop the ejection charge, and there's a couple ways you can do that. There's certain motors you can buy that doesn't come with an ejection charge, or you can cap the motors, which basically contains the charge, which could be pretty dangerous and it could just explode, but you know, you're gonna try. I'm also gonna be using slightly different motors because of that reason, because Estes, the ones I've been using before, don't really sell capped motors that can be delivered to where I am, so I'm using a different company's motors called Klima. I talked about them in previous videos, and I'm pretty sure, not by a lot, but those motors for the same size are actually slightly more powerful than the Estes D12 motors that I use for Falcon Bobby 2.0, which means that Velox E is going to actually be slightly more powerful than Falcon Bobby 2.0, and slightly bigger because the nose cone is going to actually be slightly taller, so it's going to be bigger and more powerful than Falcon Bobby 2.0 in theory. So I just want to briefly go over how the algorithm is going to work and how the rocket is going to be able to determine what stage of flight it is. So as I mentioned previously, the Arduino Nano microcontroller that I'm using comes with an accelerometer on board, and that obviously measures acceleration. So the first thing we want to be able to detect is liftoff. When does the rocket lift off? Well, that's going to be pretty easy because we can just tell the computer if there's an acceleration spike of more than a certain amount of G's, so like 2 G's of acceleration, then the rocket has lifted off. Burnout is also going to be pretty simple. When the rocket depletes all of its fuel in the motors, the rocket is going to immediately begin slowing down. So we can say when the rocket begins slowing down, when the acceleration goes from positive to negative. At that point, the rocket is still slowing down ever so slightly until it reaches apogee, and its speed or acceleration is going to be roughly 0, because when you throw something up in the air, it's going to be a brief second where it's going to be, you know, not moving at all before it starts falling back down again. So we can detect apogee by measuring what the acceleration is and if it's close to 0. However, redundancy is very important because we want to make sure that this parachute deploys, and we don't want the computer to get confused or deploy too late or too early. So we're also going to have another way of the rocket figuring out when it hits apogee and when to deploy the parachute. There's also a gyroscope on this controller, and the gyroscope basically measures the way, how much the rocket tilts in all 3 axes. So we can also say that if the rocket starts tilting a bunch, because as the rocket slows down, it's going to start tilting to go nose first down into the ground. We can say that if the acceleration is near 0 or the thing tilts too much, then also deploy the parachute. And then we can also detect touchdown as well, which is not as important because everything's already gone to plan. But if the rocket hits the ground really hard, so an acceleration spike again, then it's touchdown, and then the computer will shut off. And we'll do all this by recording flight data and logging it into an SD card so we can review it afterwards if the thing comes back in one piece. And I'll explain all that again in the next video, which I don't know when it's going to come out, so just bear with me. So that's how the algorithm is going to work. Now I'll just go over the basic design of this rocket. So this, as you can see, is the overall design of the rocket, and this is what I'm going to try and stick pretty close to. Let's start at the bottom real quick. This is the fin can, and you've got the logo here, which you can actually engrave into the thing, which is one of the advantages of 3D printing, is you can just do that and it'll print pretty well. I also have the Velox E logo that I made up right here engraved in the second fin, but as you might be able to tell, this whole fin section is actually going to be its own separate unit. This whole thing is one piece, and I intend to actually print this whole fin can out as one piece, and it'll just slide up into the rocket so that it looks like this. And we also have the airframe, and then inside this little cutout here, which is going to happen in real life, by the way, because this is how I'm going to access all the electronics on board, is the payload section, which is what I'm calling it. And this is what's going to house all of the computers. And this is what's going to look like outside of the thing. This is just a little cylinder that you're going to slide into the main body of the rocket and glue it in. And this little compartment here is where the computers are going to go, and this cap here is actually twisted, so you can twist this off and secure it on. That's why the handle is here. This white thing is the computer with the breadboard on it, and it all fits snug into there just like that. And this is just to protect the computers in case something goes wrong. Moving up, we also have this little nudge out the side of the rocket, and this is the camera case. So this is one of the coolest things, and I already printed this out. I was just one day was like, why should I keep duct taping the camera onto the sides of the rocket and risk it being destroyed? And I'm honestly surprised I got away with the camera being intact after Falcon Bobby's incident, because it was buried underneath the ground and it still works. So I decided to just design a little case for the camera to sit into, and just printed it out. This is going to go onto the sides of the rockets, just in case the same thing happens with this rocket as did with Falcon Bobby 2.0. And then moving on to the nose cone, which I've already printed the most of it out. It's pretty simple. You have the door, and you have the frame itself, and a little cap. The grey section here is the door, and this door is actually going to come off when the servo motor rotates at apogee. This little hook is where the parachute is going to hook onto. And as you can see, the servo motor is going to be nestled into the actual shoulder right here, poking out, and it's going to be holding this nose cone in place. And then when it's apogee, the servo motor will rotate out of the way, which will then open this door to deploy the parachute. It's actually very similar to the design that this guy made on YouTube. I'll link it in the description, and I'm kind of taking most of the inspiration off that video, but that's that working. And that is essentially the overall design of this entire rocket. Now, you might have noticed that a lot of those components on the rocket are decently complicated. And up until this point, especially with all my previous rockets, I have just been using things found around the house to make all these parts. However, because I'm using computers and everything, and servo motors, all these shapes need to be pretty accurate and not just like handmade or something like that. Which is why I bought this. This, my friends, if you can't already tell, is a 3D printer. Specifically, the Ender 3 V3 SE 3D printer. Naming schemes. Anyway, so this is probably one of the biggest purchases I've ever made for this whole model rocket business ever. It was about 200 quid, which honestly, in terms of 3D printers, is one of the cheapest ones you can get for everything it offers. And this isn't a 3D printing review or anything, but it's pretty good. It's just printed. Obviously, I've had a few fails. As you can see, I've already printed a few things. This is a part of the nose cone. It went pretty well. I'm not going to show you too much more of that. That's a future video. But yeah, I mean, it's pretty good. I had a few failed attempts. Like, this is half of a nose cone because it failed halfway through, which, you know, it happens. But this is very, very good, and it'll allow me to make any sort of parts that I want. Especially for Velox, because all those complicated pieces and stuff, it's very difficult to find that anywhere else, and being able to just design it yourself and then print it within a certain size limit is very, very good. It's very helpful, and it's what's allowing this whole thing to be possible. So yeah, this thing is gonna get a lot of use over the next few months. It's already has a lot of use with all these things I've printed. But yeah, it's going to be very, very handy, and I'm very glad that I've got it and got it working and everything. So that's basically everything I have to say so far about Velox E. Obviously, the next few videos will be going more in depth about the rocket's construction as it happens, and I'm planning to launch this thing sometime this summer. I'm not sure if everything goes to plan. So far, everything is going pretty well. As always, more frequent updates will always be happening in the community tab on this channel, and also my Instagram, so make sure you're following all of those things. And if you have not already, please do consider subscribing. Our channel has grown quite a fair bit since Falcon Bobby 2.0, so I really do appreciate it. It's very motivating to keep doing this sort of stuff, because obviously it's very expensive and time consuming. Anyway, thank you so much for tuning in, and I will see you in the next video. Goodbye.